Okay, hello everyone, welcome back. Today we'll be uh, trying to continue with where we ended, and here we go. The question says calculate 59.5 plus 37.4, then divide by 59.5 minus 37.4. Write down all the digits on your calculator. So that means with this instruction, write down all the digits on your calculator. That means we are supposed to use a calculator. Now, the calculators which majority of students have, uh, basically for the case of fractions, they don't write it properly. So what I would suggest, in order for you to get the answer very correct, what I would suggest is first do the numerator, do the calculations for the numerator using your calculator. That means do this one, 59.5 plus 37.4, right? The answer you get, write it here from the way how it appears on the calculator, and then do denominator. Work out the denominator, which is 59.5 minus 37.4. Then put the answer over here. You see? Then the answer you got here, divide by the answer you got here. That means take the answer for the numerator and then divide the answer you got for denominator. You see? So that will be your final answer, which you are going to write down all the digits on your calculator display. So you write all the digits of your answer which you got over here. Okay? You understand that? Now, for those who have got a calculator like this one here, for those who have got the calculator like this one here, they don't have to do that. What they do, they click on this button here. Can you see this button here? This button here is meant for all fractions. So click that. You can see the numerator and the denominator. So you type the numerator the way how it is, 59.5. Can you see that? 59.5. Then a plus 37.4. Then click a drop down menu here. Click this arrow. See this arrow? This is up, this is down. Click that and then type 59.5 minus 37.4. 37.4. Okay? 59.5 plus 37.4, 59.5 minus 37.4. So when you type everything like this, all this will be kept in place. So when you hit is equal to, you are getting the answer as a fraction. So don't copy this fraction. What you do, you place this button here. You place this button, and do you see a bar? You can see a bar over here. Now you have to press the button again for the second time. Then you will get a decimal, which they are saying write down all the digits on your calculator display. So you copy that answer over here. The answer is 4.38. Write all the digits. 4.38. 461. 461. Then 5385. 5385. See? Right. Now, this answer basically is what you come and write it here. Put it over here. Put it over here. All right. So that is your answer. 4.38461538. Good. Now, the next question is round your answer to two significant figures. Okay. So this is the answer we have got. 4.38461538. Now, can you see that this answer has how many significant figures? The first significant figure, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So this number has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 significant figures. Now, we want to write this number. Correct to only two significant figures. Okay. So what do you do? You count the first and the second because they need two significant figures. So the first, the second, you put a board over here, and then you check. You stand here. You check on your right. There is 8. 8 is bigger than 5, so you'll be adding 1 over here. This will be 4 decimal point. This will be 4. You see that? Now, what happens on 8, 4, 6, 1, 5, 3, 8, 5? All these become 8 becomes 0, 4 becomes 0, 6 becomes 0, 1 becomes 0, 5 becomes 0, 3 is 0, that is 0. Okay. For significant figures, this is the answer. This is the first answer. However, you know the theory of decimal numbers. That the zeros on the right hand side of the decimal point, these zeros may be cancelled. All these zeros may be cancelled. You see, the theory of decimal numbers, because this is not a whole number. So another answer will be 4.4. This is the second answer. Okay. So the first answer was 4.4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Another one is 4.4. So any of these two is correct. Okay? Any of these two is correct. I hope that helps. Then let us move on to the next page. Okay, this question says a calculator, this calculator you see here, gives this answer 300 divided by 19. The answer is that. Okay, what is the question? Round the answer to two decimal places. Okay, round this answer to two decimal places. You can try that. Yeah, the answer is 15.789473668. They need two decimal places, but how many decimal places are here? We have how many decimal places are here? We have 1, 2, 3, 4, 5, 6, 7, 8 decimal places. There are 8 decimal places. Now they need only two. They need only two decimal places to remain. So what we do, you stand on the first second. So you put a border over here. This is where we can estimate, or we can round two decimal places. So check on your right. There is 9. 9 is bigger than 5. So you'll be adding 1 to 8. This will be 9. This will be 7.51. Now for decimal places, the numbers remaining, the digits remaining are not becoming zeros. Remember that. For decimal places, the remaining numbers are not becoming zeros. Instead, they are getting ignored. So you ignore all these numbers. You ignore them. Don't put the zeros over here. No. If you put the zeros, that is extremely incorrect. So for decimal places, ignore the remaining numbers, and this is your final answer for two decimal places. 15.79 is the answer. You put it over there. Now, for those, if this question comes in a paper where you are supposed to use a calculator, what we basically do, I repeat showing you using, how do we use a calculator to round a number correct to the required number of decimal places? What we do, we take this number here. Can you see this number? Take this number on the calculator and then round it. Okay, let me type that. This is 15.78947368. Now, once you type the numbers on the calculator, what do? You hit is equal to, so that the calculator can, recognize the number which you have typed. Then you go to the fix option. And then click that, and then the calculator is asking how many decimal places do you need. So you only need 2 decimal places. So click that. Automatically the calculator will give you the answer, 15.79. This is the answer. Can you see the answer we got? The answer we got and the answer from the calculator, they are matching exactly. All right. So here we go. That question is done. Okay, let us see this other question. Okay, there is a conversation here. This is a problem-solving question. This is a word problem. It is a word problem question, or is a problem-solving question. Okay, so it's giving you a story. Aiko and Riri both think of a whole number. Aiko's number is 2,000 when rounded. When you take Aiko's number and round it to the nearest 1,000, it is giving you, Aiko's number is 2,000 when rounded to the nearest 1,000. So when rounded to the nearest 1,000, the number becomes 2,000. Lily's number is 1,900 when rounded to the nearest 100. Aiko says my number must be larger than Lily's number. Okay. Good. Tick to show if Aiko is correct. Explain your answer. Yeah, I guess this question you can try. Try this question and drop me a message if you don't understand. Okay, try that question. All right. Another question is, Tim thinks of a number. His number rounded to 2 decimal places is 5.46. His number, the number which you don't know, when rounded to 2 decimal places is 5.46. What is the smallest possible number Tim could have thought of? All right, let me try to draw a number line over here. Suppose this is 5.46. We are looking for the number that Tim is thinking of. Tim thinks of a number. His number which we don't know, call it X. His number rounded, when that number has been rounded to 2 decimal places, the answer is 5.6. The answer is 5.46. This is the answer. Okay. What is the smallest possible number Tim could have thought of? Okay. Now, on the number line, if this is 5.46, then the number 5.46, the number before it will be 5.45. So this is 5.45 and this is 5.45 and this is 5.46. Okay, now we can say that Tim's number, the number of this person is somewhere. Let us try to assume that the number that this person is thinking of is exactly halfway is exactly halfway of these two numbers. So let this number be x. Now x is the number, x is the number which is exactly halfway, between halfway between 5.45 and 5.46. Okay, now how do we calculate that number which is halfway? What we do, how do we calculate the value of x, the number which is halfway between those two numbers? The way how we calculate the number which is halfway the two numbers, what we do, we take this number here, 5.45, we add it to this number here, 5.46. Now the answer we get, we divide by 2. Why we divide by 2? Because that number is halfway between those 5.45 and 5.46. Halfway means divide by 2. Okay, so what we do, you take a calculator. Using the calculators which you are used to, what we do, we work out the numerator. Okay, work out the numerator, which is 5.45 plus 5.46. The answer you get divided by 2. But using my calculator, I will do 5.45 plus 5.46. Can you see that? My calculator has the ability of typing fractions. Divide by 2. 5.45 plus 5.46. When I hit is equal to, I'm getting a fraction. So I have to hit this button over here. I'm getting 5.46. But remember, we have a fixed button. We have a fixed option which is active on your calculator. So what do we do? Before you do any calculation, you have to clear your calculator. So my calculator was not cleared, so let me clear it and then repeat the procedure. So we choose this, and then we do 5.45 plus 5.46. The answer you get, divide by 2. Now can you see that I'm getting a fraction? Then I want to get a decimal. Hit this button. You see, I'm getting 5.455. I'm getting 5.455. You see? So this is the smallest possible number. 5.455. This is the smallest. 5.455 is the smallest possible number, that team thought of, that team thinks of. See that? And you can try to check. The number team thinks of the number. Now the number is 5.455. This is what we got. His number rounded to 2 decimal places. Can you round this number to 2 decimal places? And will you be able to get 5.46? The answer is yes. Put a border over here. Check on the right. There is a 5. 5 equals to 5. So you'll be adding 1 to there. You'll be getting 5.46. What happens to a 5? A 5 is ignored. So our answer is correct. So the smallest possible, what is the smallest possible number team could thought of? Okay, so the smallest possible number is 5.455. Okay, so this is the way how we do that. All right, now let us proceed with some other question. Okay. All right, 2 decimal place is 5.46. All right, let us proceed. So the smallest possible number Tim could have thought of is 5.45, because 5.455, because when you round this number to 2 decimal places, you are going to get 5.46. All right. Okay. Next question is this one here. Here we go. The distance from the Earth to the Sun is 92,868,000. Okay. Write this distance correct to 3 significant figures. All right. So you take that 92,868,000. Okay. They need 3 significant figures. How many significant figures are here? 1, 2, 3, 4, 5. These zeros are not significant figures, but don't cancel them, because this is a whole number. This is a whole number. You see, don't touch the zeros in the whole number. It's very dangerous. In the decimal number, yes, you can cancel that, but be careful. Okay, so they need 3 significant figures. How many significant figures are here? 1, 2, 3, 4, 5. These are not significant figures. Don't touch them. Don't cancel them, because that is a whole number. All right, 3 significant figures. 1, 2, 3. So you put a border over here. Check on your right. There is a 6. Add 1 here. You'll be getting 9, 2, 9, 2, 9. Okay, what happens on this? 6, 8, 0, 0, 0. 6 becomes a 0. 8 becomes a 0. 0 remains a 0. 0 remains a 0. 0 remains a 0. This is the answer. They need 3 significant figures. 9, 2, 9, 0, 0, 1, 2, 3 miles. This is the answer correct to 3 significant figures. Do not, never, do not cancel this 0. And you get 9, 2, 9. This is the correct answer. So I said, in a whole number, don't cancel the zeros. Never cancel the zeros. Leave the answer with the zeros. Okay, the length of a nail, the length of a nail rounded to 1 decimal place is 6.9. Write down the shortest possible length. This question is similar to this question. This question is similar to this question here. Tim thinks of a number. His number rounded to 2 decimal places is 5.46. What is the smallest possible number Tim could have thought of? See, this is the working. So the smallest possible number that Tim could have thought is 5.455. Okay, the smallest possible. Now this question, the way I've done this question, I'm going to repeat doing the same question. Same method. The length of a nail when rounded to 1 decimal place is 6.9. Write down the shortest possible length that the nail could be. Okay. So what I do, I take a ruler. And draw a number line, a very simple number line. Okay, so this is my ruler. I take this is my ruler. Then on it I draw that the length of a nail rounded to 1 decimal place is 6.9. Okay, this is 6.9. Okay, now the question is, write down the shortest possible length that the nail could be. Okay, 6.9, the number below it, the number below 6.9 is 6.8. Okay, so the shortest possible length will be halfway Okay, let this be, say, y. Okay, so y, so here we say the shortest possible length that the nail could be. So the shortest possible length that the nail could be is y, which is exactly halfway the two numbers, halfway the numbers 6.8 and 60.9. Now, how do we calculate the number which is exactly halfway between the two numbers? So what we do, the number which is y, exactly halfway, you do 6.8, this number, plus this number. The answer you get, divided by 2. Same working, yeah? Okay, so this will be 6.8 plus 6.9. Okay. Nope, let me choose this button. 6.8 plus 6.9. The answer you get, divided by 2, because I'm looking for the number halfway. Okay. What is the answer? 6.85. Very good. So here is 6.85. That is the smallest, 6.85. This is the smallest possible number. This is the shortest possible number that the length could be. This is the shortest possible length that the nail could be. Okay, let us now try to check if our answer is correct. If 6.85 is the smallest, is the shortest possible length the nail could be, let us try to round this number to 1 decimal place, and let us try to see if we get 6.9. Okay, this is the smallest possible, 6.85, the smallest. Okay, can we try to check if it is, when rounded to 1 decimal place, will give me 6.9? The answer is yes. Okay, 1 decimal place, keep a boundary over here, check on the right, there is a 5. Now equal to 5, we'll be adding 1 there. This will be 9, this will be 6.9, you see? So we are correct. And this 5 is ignored. Don't put 0 here. You are going to get again 2 decimal places. So don't do that. So our answer is correct. Right. Around each of these numbers correct to 2 significant figures. My goodness, 2 significant figures. I've taught you significant figures, but let me do it. We have this number 178.65.2. Okay, now we need 2 significant figures, but the question is, how many significant figures are here? 1, 2, 3, 4, 5, 6 significant figures. Some other students get confused when they get a decimal point. When they get a decimal point, they think that the number after the decimal point should not be counted as significant figure. You ignore. When counting significant figures, try to ignore a decimal point. Try to ignore that, and then count everything. Whatever is there will be your significant figure. But 0 is not a significant figure. Remember the story. Remember the story behind. Okay. All right. So what I'm going to do is I'm going to check out how many significant figures are here. 1, 2, 3, 4, 5, 6. So what is the number of significant figures? So there are 6 significant figures. There are six significant figures. Now they need 2. So 1, 2. Keep a boundary over here. Check on your right. There is 8. Add 1 over here. You know the theory. This is 8. This is 1. What happens on 8? 0. What happens on 6? 0. What happens on 5? 0. Point. What happens on 2? 0. So answer number 1 answer number 1 is 1800.0. This is the answer number. Answer number 2, do you remember the theory? A 0 after the decimal point can be cancelled. So 18000. Please, I repeat, this is a whole number. 18000. This is a whole number. This is a whole number. Never cancel the zeros and you write the answer 18. This is incorrect answer. Okay. All right. Okay. All right. So you can pause the video and try to take a good look for that. Another question is this question over here. Round each of these correct to 2 significant figures or same instruction at different numbers. Okay, 0.006047. Okay, they need how many significant figures? There are 2 significant. They need 2 significant figures. But how many significant figures are here? We have. Let me take this number, put it over here. Okay. We have how many significant figures? Okay, 0 is not a significant figure. This 0 is not a significant figure. Do you know the reason why? It is not in between non-zero digits. So 0 is not a significant figure. This 0 is not. This 0 is not. This 0 is a significant figure. Why? It is because that 0 is between 6 and 4. Non-zero digits. So this 0 qualified to be a significant figure. All right. Now, how many significant figures are here? 1, 2, 3, 4. So there are 4 significant figures. Some other students will start making mistakes, cancelling these zeros because the teacher said they are not significant figures, and then they remain with the number 6047. I repeat, this is incorrect. What I mean here is when I say those zeros, when I say these zeros are not significant figures, does not give you a direct ticket for you to cancel them. We are just trying to refer to them as not significant figures because we don't want to count them. But when it comes to writing them, we have to write them, because they show the value, that the value of this number is 0.00. So when you cancel these zeros, then you are getting another new number which does not exist for this question. You see? So don't cancel that. Don't count them, but don't cancel them. Don't count them as significant figures, but do not cancel them. All right, 0. Okay, now there are 1, 2, 3, 4 significant figures. They need 2 significant figures. Okay. The first significant figure starts with a 6. Second significant figure starts with a 0. And then 4 is the third significant figure. 7 is the fourth significant figure. Now, they need 2 significant figures. Okay, so what do? We keep a boundary here, and then check on your right. You see that? There is a 4. Now 4 is not bigger than 5. So you will be adding 0 to a 0. Now this is where confusion arises. 0, 6, 0, 0, 0 point. See that? Now, what did I say? 4, 7. 4 becoming 0, 7 becomes 0. Now, remember what I said? Answer number 1 is 0.006000. Can you see that? Let me check. 0.00600. Very good question. It looks confusing. Now, to get answer number 2, remember what I said, that the zeros after the decimal point on the right, the zeros after a decimal point to the right can be cancelled. Now, this is where confusion will start arising. See? Some people will start cancelling all these 3 zeros. Yeah, because the teacher said you can cancel the zeros on the right hand side of the decimal point. They are right. They are trying to quote the teacher. But they are forgetting that this zero was a significant figure. So this zero here was part of our significant figures. So when you cancel all the zeros, you are losing our zero, which was a significant figure. Can you see that? Now the zeros which you can opt to cancel are these ones here. Those you can opt to cancel. Never cancel this zero, because originally this zero was a significant figure. You see? So this will be 0.0060. I hope here I can get some students who can get confused, but this is the fact. Okay? The zero you can see here, this is the zero you can see here, was this zero here, which was counted as a significant figure. So you don't have to cancel that. Okay, I hope that helps. So let us proceed. Okay, let us proceed. All right, next part will be this one here. Right. What that? Good. Here we go. Write the number correct to 2 decimal places. This I've taught you many times, using a calculator and using your mental ability. So this you have to try. No excuse. Significant figures, this also you have to try. No excuse. Okay, but still, if you don't understand, then you can drop me a message, then I will come back to you. All right, we have a conversation here, a conversation between two people. Let me check how much time has gone. 37 minutes, okay. Here we have got a conversation. This conversation is between Mia and Paul. Okay, Mia and Paul are looking at the same whole number. They are looking at the same whole number. To the nearest thousand, it is 44,000. To the nearest thousand, it is 44,000. To the nearest 10, it is 44,000. Okay, very good. To the nearest thousand, it is 44,000. To the nearest 10, it is 44,000. Oh, very good question. They are both correct. Write down one possible value of the number. Try this question. It looks very challenging, and come back to me if at all you get a problem, if you face a problem. Okay? Otherwise, for today, let us stop here. I will be back later. Bye-bye for now.